Thank you very much for having me here today. What we are going to do, we'll be covering the concepts of empirical molecular formula for organic compounds. A few months ago, we have looked at empirical molecular formula, but for today, we'll be looking at the empirical molecular formula of organic compounds, and that includes the percentage abundance as well. So I'll be guiding you through on what are the calculations involved and how do we break down the concepts of percentage abundance, empirical molecular formula. So we'll go straight to the lesson right now. Alright, so if we look at this particular chapter, which is on page number 225, and it says here, calculate percentage composition of organic compounds. The percentage composition of a compound tells us the proportion by mass of the different elements in that compound. And it says here that to determine the percentage composition by mass of a compound, divide the mass of each element present by the mass of the whole sample and express the result as a percentage. So the equation that we have is mass of the element divided by total mass of that compound multiplied by 100%. So I'm going to show you an example of how it looks like. So if you look at this particular example here, it says here 2.85 gram of an organic compound contains 1.52 gram carbon, 0.45 gram hydrogen, and 0.88 gram of nitrogen. So they're asking for what is the percentage composition. Using the formula, it says the percentage of that particular element equals to mass of the element divided by the total mass of the compound multiplied by 100. For example, if you look at the percentage of carbon within the organic compound, we have 1.52 divided by 2.85 times 100. How we get 2.85 will be combination of all the elements within the organic compound. So within the organic compound, we have 1.52 plus 0.45 plus 0.88. So it comes up to 2.85 gram as the total mass of the compound. And then you will be able to calculate the percentage of carbon, percentage of hydrogen, and the percentage of nitrogen. If you want to make sure that your answer is accurate, when you add these percentages together, it comes up to 100%, which means that your answer is correct. So this is how percentage composition looks like when you're doing the calculation. As mentioned before, we have done this a few months back on the percentage abundance, but for today's lesson, that is specifically for organic compounds. So if they ask you a question, how do we calculate the percentage abundance of the different elements within the organic compounds, you will be able to do the calculation. We are going to look at the second part of today's lesson, which is on empirical formula. So if you look at this particular topic, which is on empirical formula, it says that an empirical formula gives the simplest whole number ratio of each kind of element in a compound. For example, the molecular formula of glucose is C6H12O6 and its empirical formula is CH2O. So when we are talking about the empirical formula, it is the simplest ratio, whereas the molecular formula is the actual formula or the actual chemical formula for that particular compound. So if we look at this particular slide here, it's just telling you on how do we calculate the empirical formula. So the example given here is an organic compound is found to be composed of 52.2% carbon, 13.0% hydrogen, and the remainder is oxygen. Calculate the empirical formula of the compound. So what you need to do here, you need to assume that the total mass of the compound is 100 gram. So the mass of carbon will be 52.2 gram, hydrogen will be 13 gram, oxygen will be 100 minus 52.2 minus 13, you will get 34.8 gram. Once you have obtained the mass of each element for that particular organic compound, you can calculate the number of mole equals to mass divided by molar mass. So you can calculate the number of mole of carbon, number of mole of hydrogen, and number of mole of oxygen. And once you have done that, you have to divide all of the number of mole by the smallest number of mole, which gives you the ratio, and this ratio is important. That will tell you how many carbon is present when you have a certain number of hydrogen and oxygen. Alright, something for you to think about. So there is an example that is being given here as well. So let's just say that this example has a percentage composition of 40% carbon, 6.7% hydrogen and the remainder is oxygen, we know that the total mass is of 100 grams. So we assume that the total mass of the organic compound is 100 grams. Once you have done that, you can find out the mass of carbon will be 40 gram, mass of hydrogen will be 6.7 gram, and the mass of oxygen is 53.3 gram. You can calculate the number of mole, which is mass divided by molar mass. Then you simplify the ratio by dividing each number of moles by the smallest number of mole. You have the ratio of carbon to hydrogen to oxygen will be 1 to 2 to 1. So the simplest whole number ratio will be 1 to 2 to 1. So when you write down the empirical formula, it will be CH2O. Alright, so that is what empirical formula is. If you look at this particular slide here, it's just telling you on how to determine the mass of oxygen in the organic compound. So basically, once again, you have to find out the mass of each element within the organic compound. You can then calculate the number of mole. Once you have calculated the number of mole of each of the compound, you divide by the simplest ratio. That will enable you to find the empirical formula for that organic compound. Alright, so that is the general idea of what an empirical formula is. So make sure that you are able to answer any questions on the empirical formula, and you're very welcome to post me any questions in regards to empirical formula. So we'll move on to the last part of today's lesson. So if we look at this particular concept here, we have to determine the molecular formula. It says that the molecular formula of a compound can be determined if you know its empirical formula and its molar mass. The molar mass of a compound is the mass of 1 mole of the compound. For example, the molar mass of water is 18 grams per mole. So you have the empirical formula of the compound. Once you have determined the molar mass of the empirical formula and of the compound, you can find out the number of empirical formula units in the compound. Then you can write the molecular formula. So how does this work? So if we look at this particular example given, so this particular compound has an empirical formula of CH3. The molar mass of the compound is 30 grams per mole. So in this case, the molar mass of CH3 will be 12 plus 3 times 1, you get 15. So we know that the number of empirical formula unit will be 2 because the molar mass of the actual formula will be 30 grams per mole. But the molar mass of empirical formula unit is 15. So if 30 divided by 15, you will get 2 at the end. So if you look at this particular example here, so if it says that the compound has the empirical formula CH, so 1 carbon 1 hydrogen, for its empirical formula, you know the molar mass of the compound is 78 grams per mole. So step number 1, you will find out the molar mass of carbon and hydrogen, which is 12 plus 1, we get 13. And then you can find the number of empirical formula unit, which is 78 divided by 13 equals to 6. And at the end, you will have the molecular formula unit, which is 6 multiplied by carbon and hydrogen, you get C6H6. So C6H6, which is an example of a hydrocarbon, will be the molecular formula of the compound. So in general, what we have done today, we have looked at the percentage abundance, the empirical formula, and the molecular formula of the hydrocarbons and organic compounds that we have covered in class. So make sure that you know the difference between percentage abundance, which is the percentage of each element within the compound, and when we are talking about the empirical formula, we are talking about the simplest ratio. It is not necessarily the same as the molecular formula. Sometimes they can be the same as the molecular formula. So when we are talking about molecular formula, that will be the actual chemical formula of that particular organic compounds. Alright, you're very welcome to post me any questions, and I will see you